Dosage Calculations. Here we're going to look at 3 different formula to calculate the required dosage of a medicine for a child. Now, the 3 formulas we're going to look at, first one's called Freed's formula. So we've got Freed's, that's an E. So Freed's formula, which is the dosage required, is going to be M times A divided by 150. We're going to look at Young's formula, which is the dosage required is going to be Y times A divided by Y plus 12. And then finally Clark's formula, which is the dosage required equals K times A divided by 70. Now what does all these things mean? So over here the M is the age in months. The age in months. Your A for all of them is the same. It's the adult dosage required. Your Y in this one is the age of the child in years. So the age in years. And for this one, a K is the mass of the child in kilograms. All right, let's have a look at an example because it's mainly just a matter of plugging some numbers into the formula. Okay, so this one is asking us to use Freed's formula. So we're using Freed's formula to find the dosage required. So our dosage required for a 1-year-old child, if the adult dosage is 50 milliliters. All right, so Freed's formula is our dosage is M times A over 150. So here you have to be careful because M is the age of the child in months, but it's a 1-year-old, so 1 year is 12 months. And the adult dosage is 50 mil. Nice and simple. And just a matter of plugging those numbers into the formula. So we get 12 times 50 divided by 150. And that's going to give us 4 milliliters for our dosage for the child. Let's have a look at another example. So in dosage calculations, you could also be looking for a flow rate. So if we have a patient and they're to receive 1.2 litres of fluid, 1.2 litres of fluid over 4 hours through a drip, and we get 15 drops per milliliter. How many drops per minute are required? How many drops per minute are required for this patient? All right, so we know our flow rate is supposed to be, 1.2 litres every 4 hours. All right, so a nice way to write that is 1.2 litres divided by 4 hours. Now, we need in drops per minute. So, but we know a drop, as we can see over here, we have a relationship between drops and milliliters. So we want to change our liters to milliliters and definitely want to change our hours to minutes because we have this minutes here. So let's go ahead and do that. So to change liters to milliliters, we'll times by 1,000. And to change hours to minutes, we'll times by 60. So if we do that, we'll get 1,200 milliliters over 240 minutes. We can tidy that up a little bit, so we can just divide these numbers with each other, and that'll give us 5 milliliters per minute. But we want to know how many drops per minute that is. And we know there's 15 drops for every milliliter. So we simply have to multiply this by 15, our number of drops per milliliter, and that's going to give us 75 drops per minute.